So, as a kid, did you ever wanted a mini train set? Well, me neither, but now I see it quite interesting. This is how I made it. I started with the track because it's the easiest part of the project, and I decided to implement a custom scale, 1:50, because for me the standard 1:87 is a bit too small. I found some gauge dimensions, rail profile and the track slipper's rough shape, and after that I did some complicated calculations to find the downscaled sizes. For some additional information about the track, which I didn't find at first glance, I searched very deep, and in the end I got everything I needed. Next I started modeling the sleepers in the rail, and I was afraid that the overall model will be brittle, so I considered enhancing the track, even though the dimension will no longer be at scale. I mean, it's still 1:49.8-ish. After I finished the base model, using my unseen 3D modeling skills, I got to design the track couplers. Well, tweaking the tolerances, I finished the couplers and they looked functional. Kind of. I added some supports and sliced a small version of the track, and after it was printed, I ran some tests. The filament I used is a Polylite PLA, and even though it's quite ugly, just for testing is fine. After this test, I decided to change the track design and fix the coupler's backlash. This version is way better looking and feels much sturdier. I played with the new coupler's tolerances until I found the best fit to minimize the play. Being satisfied with the overall results, I made a curved track, 15, 30, 45 and 90 degree with a radius of 20 centimeters. All the versions are meant for a small 3D printer bed size, so you can even print the big 90 curved track, if you really want to. Next I wanted to see how the layer height and the nozzle diameter influence the printing quality and time. I tried 3 different settings, and I also tested my brand new AMS, which did a very good job at printing with different colors. Here are the results. First test was made using the most common 0.4 nozzle with 0.2 layer height, and of course, you can see the layer lines, and for me, that lowers the quality a lot. The second print was made using the same nozzle, but 0.08 layer height, and the difference is massive. The layer lines disappeared, and the small details are very clear. The last, but not the least, was the 0.2 nozzle with 0.06 layer height, which to be honest is the same as the previous one, only the printing time increased. After all these tests, for me, the second one is the winner. In future, I will try the adaptive layer height to see if I can decrease the printing time even more. But with these prints, I noticed some humidity issues with my filaments, and searching for a solution, I came across this guy. So I got to work. I added a humidity sensor and for safety, a gas detector and a buzzer. After some coding, the filament dryer was ready. I set the bed temperature at 70 degrees, and starting with 64% humidity, it got to 18 in about 3 hours. So it's quite reliable. Solving this issue, I switched from this to the rolling stock. I designed the wagon wheels using downscale dimensions, and after printing them, I ran a couple of tests. The tolerances are perfect, so the wheels do not need any glue. Rolling on the track, I noticed they work like the real ones, recentering by themselves, which was a very good sign. Speaking about strength, it's okay. Next I designed the bogie, trying to implement as many details as possible. The lack of real-life pictures made this a bit hard, but in the end it turned out pretty. I printed this model using the 0.2 nozzle due to the really small details, and it turned amazing. After designing and printing the sides connector, I assembled the bogie. There were some small flaws, but I fixed them in the next versions of the bogie. If you wonder why I didn't use bearings, well, the purpose of this video is to make a mini train set fully 3D printed, or as much as possible. Even without bearings, the bogie rolls well, although it needed some improvements. Making the pivoting system, which is just a cylinder with 2 screws, I got an idea of a suspension. Being a bit ambitious, I made different versions of springs to see if they are reliable. Spoiler alert, they're not. After I assembled the full bogie, I tested the springs and decided to go further with the fourth version. But wait a second, we need to take a break. Okay, back to work now. I started designing the wagon chassis, making sure to keep the right proportions as much as possible. Very few dimensions were published online, so I relied on my perception. The hardest part was to divide the chassis in such a way that it fits on the A1 mini printer bed, but in the end it was almost finished. I then moved to the wagon body, which was a lot more complex than the chassis due to its more details. Designing the body was a bit tedious, but after some time adding all the details, it turned out great. To finish the chassis, I started working on the buffers and on the train couplers. After some trial and error, the buffers were functional. Designing the couplers, I realized the non-realistic magnetic ones will do the job, even though I will encounter some symmetry issues later on. But that's future problems, right? So I tried different configurations until I found the best one.
Oh, you touched my tra-la-la.
Another spoiler alert, it wasn't the best one. Printing the first part of the chassis, I noticed some warping, issue that I solved later on by turning off the cooling fan for the first 4 layers and decreased the bed temperature to 55 degrees. You can modify these settings in the slicer, and if you had the same problem, please let me know in the comments if this worked for you. Next I connected the bogie to the chassis and added a buffer and a coupler to test if they fit. Printing all the chassis parts, I started assembling. This took a while, but it was rewarding to see that everything fits. For this prototype, I didn't bother to print new chassis parts, even though the warping was prominent. The last parts assembled to the chassis were the bogies, which due to my skill issue, took longer than expected, but was finally done. Do you remember my ambition? So I removed the suspension, for now. Dividing the wagon body was a pain in the and took so long, but it was finally over. Then, after 19 hours of printing, you'll know why it took so long later in this video, I assembled the top part of the body. This was satisfying and the print turned out quite strong. After adding some small details, I assembled the other parts which strengthened all the body, and suddenly all the prints became one single block. By the way, the length of this wagon without the buffer is almost half a meter.
Oh my god, who the hell cares?
Moving to the other details, I added the windows and the seat class number, and after that I assembled the wagon doors, which I glued later on to the body. Next, the front and back was added, which gave a better look to the whole wagon. Then I connected the chassis and the body together and added the info panel. The last steps were to assemble the front and back doors, to change the couplers in order to fix the symmetry issue, and to add some backlights. And after many days of designing and printing, this is the result. Speaking about printing time and filament use, I printed all of the parts mostly using 0.4 nozzle with 0.08 layer height, and for bogies, the 0.2 nozzle with 0.06 layer height. And for one piece of straight track, it takes 1 hour and 37 minutes to print and 13.7 grams of filament, or less if you don't use brim and supports. For one whole wagon, it takes 78 hours of printing time and 588 grams of filament. You can decrease a lot the printing time by using higher layer heights, but you'll sacrifice the quality. You can find more details about this project in the description of this video or on my GitHub link below. With that, thank you a lot for watching this video, and I'll see you soon with the second part of this project. Stay safe. You better like and subscribe.